Hi, this video is all about percents. What is a percent? Well, a percent is a way to represent or mean something per hundred, and it's used to compare an amount to a quantity of 100, and it's expressed as part of 100, and it's written with the percent sign here. These are just some common percents that we see pretty regular. Now, there are things we have to do with percent, and we have to be able to take a percent and convert it to a decimal to be able to use it in mathematics. So the way you do that is basically you're dividing by 100. Well, if you'll remember, dividing by 100 is just moving your decimal 2 places to the left. So you would drop the percent sign and move it 2 spaces to the left. To convert from a decimal to a percent, you would just basically do the opposite. You would move the decimal 2 spaces to the right and add the percent sign. That's it. That's all you have to do. So let's look at some examples. Convert either to a decimal or to a percent, and they tell you which one you have, and you're going to go to the opposite. So number 1 here says 54%. So we're going to convert that to a decimal. So it says move our decimal 2 places to the left. So our decimal is here, and we would move it 2 places to the left, and so it would end up in front of the 5. And so 54% is the same as 0.54 as a decimal. All right, we have a decimal here, and we're going to convert this to a percent. So we have to take our decimal, move it 2 places to the right. So it would end up at the end of the 6. And so 0.36 would be 36%. All right, think about 17% for a second and see if you can come up with the answer. Moving our decimal 2 places to the left, we would end up in front of the 1, so it would be 17.17. Now, it's okay if you want to put the 0 in front of that. It's not necessary. It's just however you feel comfortable writing the decimal. Okay, what happens here, we have a decimal, but we only have 1 spot to move our decimal to get our percent, but we have to move it twice. What number do we have to put in to placehold that? And that would be the 0. And so 0.9 would become 90%. Okay. All right, number 5. I've had students over the years that say, well, that's already a decimal. It is, but it's not a decimal that we can use because it still has the percent sign. To get rid of the percent sign, you have to move your decimal 2 places to the left. And so we move it, end up in front of the 1, and so we end up with 0.115. And then on the last one, 0.289, moving it to a percent, moving our decimal 2 places. It becomes between the 8 and the 9, so we end up with 28.9%. Okay, so there's a lot of more things to do with percents, so hang with me, pause, take a break if you need to, come back. All right, so now we need to write a percent to a fraction. All right, so to write a percent as a fraction, it says drop the percent sign and write the number over 100, and then reduce the fraction if necessary. So let's look at our first problem, 17%. So if we were going to write this as a fraction, we would just simply write 17 over 100. Can 17 over 100 be reduced? 17 is a prime number, so no reducing is necessary. All right, next problem. 25%. So we would write this one as 25 over 100. Or if you've learned your benchmark fractions over the years, you would automatically know that that is 1/4, or also known as 1/4. And that stems from our money system. 25 cents is a quarter in our money system. All right, 40%, we would write it as 40 over 100. That can reduce to 4/10 because I just took off the 0. And then this is a little easier to reduce now. And 4 and 10 have 2 in common, so divide by 2 and get 2/5. And reducing, you can reduce however you feel comfortable. If you knew that 20 would go into both 40 and 100, you could have reduced it by 20 and immediately gotten the 2/5. And the last one, 33 1/3%. Ooh. Okay, so now we have a decimal over 100. This is where I was talking about those benchmark fractions. And hopefully by now, you would, if you just apply the rule, you would get 33.3 over 100. But hopefully you know that that is approximately 1/3. Okay. All right, now we're going to convert our fractions to percents. To write a fraction as a percent, you divide the fraction to get the decimal, and then move the decimal 2 places to the right, and then add the percent sign. Okay. So 1/2 we would divide. So let me move over here and divide 1/2. The top number goes on the inside, the bottom number goes on the outside. Can't divide into 1, so we have to put our decimal, carry it up top, bring our 0. Now in the problem, you can ignore the decimal at this point because you've taken it up to the top. So you're dividing 10 by 2. Well, 10 divided by 2 is 5. We subtract and we get 0. So we have no remainder. So our 1/2 is equal to 0.5. And then we're applying the rule to convert a decimal back to a percent. Move our decimal 2 places to the right. And so we would get 50%. All right, let's divide 7/8. Top number goes on the inside, bottom number goes on the outside. Can't divide into 7, bring in the 0. 9's too many, so we use 8. So that would be 64. Subtract. 10 minus 4 is 6. Add a 0, bring it down. 8 into 60. Well, 8 won't work, so let's try 7. That's 56. Subtract, we get 4. Add a 0, bring it down. So that would be 5. And we know that 8 times 5 is 40, so we can stop there. So our 7/8 equals 0.875 as a decimal. Moving our decimal 2 places to the right, we would end up with 87.5%. Now, I want to point out something. Half. Okay, look at half. We know that half is 50%. We also now know that 7/8. Well, looking at fractions, sometimes it's hard to tell which one is larger in value. And so whenever you convert it to the percent over here, you can easily tell that without me marking on the screen, you can tell that 50 is less than 87.5. And so it makes comparing the numbers a little easier. All right, take a second, try 3/5 and 1/3, and let's see what happens. I'm going to use this side over here. Top number goes on the inside, bottom number goes on the outside. 5 into 30 is 0.6. So we end up with 0.6. Move our decimal 2 places, so we need a placeholder. So we end up with 60%. And again, if you've memorized your benchmark fractions, you know that 1/3 is 0.3 repeating. It just keeps going on forever and ever and ever, and I'll show you when I divide in just a second. And so we would have 33.3 repeating percent. And most of the time we round that to approximately 33%. If we divide it, top number goes on the inside, bottom goes on the outside. 3 into 10 is 3 times. That would be 9. Subtract, you get 1. Bring down your 0. You get 10 again. So you see the pattern here? We're going to always keep getting 3s. So it's going to keep going forever. It's going to repeat. Okay. Now, there are some things we do with percents, everyday times, and you need to be able to find the percent of a number. Now, this is just a proportion, and it's set up as this equation: part over whole equals percent over 100. Now, I have these lines drawn here to remind you of proportions, and the way proportions work is this times the cross products are the same. So the part times 100 would equal the whole times the percent. And it always works if you set it up in this particular way. Now, I'm going to show you how to use this. And here's basically the rule. Okay, it's a proportion with 3 changeable sections: the part, the whole, and the percent. So the part will change, the whole will change, and the percent will change. The 100 is just 100. It never changes. There's nothing to change it to because percent is always over 100. You'll be given 2 of the sections, and your task will be to find the missing value. Using a variable for the unknown, that would be a letter that you put in for the unknown, you solve the proportion by cross-multiplying the numbers without the letter and dividing by the number with the letter. Okay, I know that's clear as mud. I'm going to show you how it works. Here's some problems. Okay, 18 is what percent of 72? Okay, here's our equation down here. I don't know if you can see the yellow, but hopefully you can. I just wrote it down here to help you remember for a few minutes. All right, so we need to label what these are, okay? And remember, part's key word is. You see the word is, that's telling you the part. The of is telling you the whole. And the percent is telling you percent, okay? So when we go up here and we find the is, get my highlighter, there's my is what number? 18. And then we find the of right here, and that tells me my whole. So let's fill in our proportion. The part goes on top, so that's 18. The of goes on bottom, so that's 72. And our percent is our unknown, so we use a letter. I usually use the letter X. It doesn't matter. You can use whatever letter you want to hold my placeholder. That's what I'm looking for, over 100, because we know that doesn't change. Okay, I know that 18 over 72 can reduce. I'm going to reduce that first because it makes solving this problem easier. So 18, I know I can reduce it by 9, so let's try 9. So if I divide by 9, I get 2, oh, wrong color. If I divide by 9, I get 2 over 8, okay? And I know that'll reduce again to give me 1 over 4. So that's the number I want to use in my problem because it's a whole lot easier to use. So I'm going to come down here and rewrite this as 1 over 4 equals x over 100. Now, if you have a calculator or you're allowed to use a calculator, you don't have to do that. You could have just multiplied 18 times 100 and then divided by 72. We're going to multiply 1 times 100, which is 100. And that's our number that goes on the inside. And then we're going to divide by 4. And then we just work that out. So that's going to be 4 into 1 can't work. So we move to 10, that'll be 2, which is 8. Subtract, we get 20. 4 into 20 is 25. And so what 18 is what percent of 72? It would be 25%. And make sure you label your percent there because that's what we were looking for, is our percent. So that's how you use the proportion. We're going to do some more. All right, part over whole equals percent over 100. You're setting it up. That doesn't move. You leave that alone. Okay, so let's label what we have here. 22%. That's pretty easy. We have a percent, right? Of 150. There's our of 150 is, let's go to orange, is how much? That's going to be our variable. So if we plug this in, part is our unknown. There's our variable, so that's our x. Of is 150, so x over 150 equals percent. Well, it's right there. It has the percent sign. So 22%, 22 over 100. Because you're writing that percent over 100, you don't use the percent sign at this point. Okay. So now we just need to decide what we multiply. Remember, I told you cross products. So if it helps you to circle them, go ahead and do so. The 100 goes with the variable. The 150 and 22 are together. So we multiply the numbers without the letter and divide by the number with. Well, in this case, dividing by 100 is easy. So let's multiply 150 times 22. Now, I put the 150 up top because it's easier to multiply 3 digits by 2 digits when the 3 digits is on top. 3 digits are on top. So, multiplying. All right, 2 times 0, 0. 2 times 5, 10. Carry your 1. 2 times 1 is 2 plus 1 is 3. Because this is the same number, bring down your 0 for holding that place value, and then repeat. 0, 0, 3. Now add. So we have 0, 0, 3, 3. So we end up with 3,300. Now, what is the rule for dividing by 100? We have our 33 divided by 3,300 divided by 100. Anytime you're dividing by 100, all you have to do is move your decimal 2 places to the right. So we end up with 33. And so 22% of 150 is 33. Six is 35% of what number? Okay, so let's see if we can do this without highlighting this time. All right, 6 is, so, oh, I don't have my proportion. Let's see if we can remember it. Part over whole equals percent. Over 100. I know that's a little messy, but it'll be all right. All right, so is my part. 35% is my percent. And my of is my variable. So part is 6. What number is my variable, my of? My percent is 35 over 100. Okay. Multiply the two numbers that are together. Cross products. 6 times 100 is 600. Divide by the number with the variable. So divide by 35. Okay, so I didn't realize I made this one a challenging one, but we'll do it. All right, 35 into 60 is 1 time. Subtract. Bring down the 0. Okay, and I'm going to stop there because it's okay to round. And so we're going to stop at that point. And so we get about 17.1. Now, this number is not a percent because it's our number that we were looking for here. It's our whole amount that we were looking for. Okay? All right. What percent is 15 to 10? Oh, this one's a little harder. It doesn't actually tell us which one's which, but it does. Okay, let's see how. All right, first off, we're looking for our percent, so that's going to be my variable. So we know we have x over 100. Okay, now it says is 15. What percent is 15? So our part is up top. And our whole, it doesn't say of 10, but it says to 10. And that tells you that's what your whole is, because your is was 15 and the only place left is your whole. Now I noticed something. 15 is larger than 10. So what should you know about your percent value here? You should think that it's going to be larger than 100 because these have to be equal. And here's another way to solve these. You can still do your cross multiply and divide, or how many times do we multiply 10 by to get 100? Well, we would just have to multiply it by 10, and so we would have to multiply 15 by 10, and so we would get 150%. So the percent of 15 to 10 is 150%. Okay? All right, last one on this particular proportion. On a 125 question test, a student got 90 correct answers. What percent of the problems did the student work correctly? All right, we're looking for our percent, so we're setting up our percent over 100. Now we just have to decide what is the part and what is the whole. Well, if you think about a test, the number of questions on the test is going to be your whole. And then how many you got correct is your part. That's the part that you got right. And so I'm going to work this one out. So 90 times 100 is 9,000. Just add the two zeros. And then I'm going to divide by 125. All right, let's see. Can't do 9, can't do 90. 900 by 125. 8 wouldn't work, so let's go with 7. So that's 25, carry the 2, 14, 15, 16, carry the 1, 7, 8, 8. 65, that should not be right. 35, carry the 3, that should be a 7. So then that brings down 25, bring down the 0, and it's okay to make mistakes. You can fix them. How did I know that it wasn't 65? Because 25 doesn't give you a 65. It only adds to give you 25, 50, 75, 100. 125 into 250 is 2, which is 250. So this person made a 72% on their test, getting 90 out of 125 questions correct. Okay. I know I have those little pauses in there. Hopefully they're not too annoying to you. I put them so if I have to splice the video, I can do so. Okay, so moving on. All right, there are things you have to find using percents. You have percent increase or decrease. And all you have to do on those is to decide whether it's an increase, the price is going up, or if it's a decrease, your price is going down. The steps or the process is the same for either. You just have to indicate which way your amount is moving, more positive or lower, higher or lower. All right, so if it's asking you to find a percent increase or decrease, you need to always just take your large value, the largest value, subtract the smallest value, and then divide it by the original. Okay, I'm going to say that one more time. You take the largest amount, subtract the smallest, and then divide by what you started with, or your original amount. After you divide that and you get your decimal, just change the decimal to a percent by moving it 2 spaces to the right, moving your decimal 2 spaces to the right. So, let's look at what that looks like. The price of a shirt was reduced from $50 to $35. By what percentage of the price was the shirt reduced? Okay, so this is going to be a percent decrease. Now, how do I know that it's going to be a percent decrease? Well, it's because I know the keyword reduced, and then if I look at 50 to 35, 35 is lower, so it went down. So our rule says subtract the larger amount by the smaller amount. So we take 50 minus 30, and then divide that by the original. So we started at 50, so we divide by 50. And so that's going to give us 50 minus 30. You always do the numerator first. So that's going to give us 20 divided by 50. Because I know that I can count the zeros off, I get 2/5. So I'm going to divide 2 by 5. And so I'm going to get 0.4. And if I get 0.4, to change that to a percent, I move my decimal 2 places to the right. So that would be 40% decrease. The shirt went down 40%. A collectible car's price has changed from $200 to $250. By what percentage has the price of the car changed? Okay, so remember the formula. It says take your larger amount, 250, subtract your smaller amount, and divide by your original. So I'm changing it from 200, so that would be 200 here. Remember to do the numerator first. 250 minus 200 is $50. And then divide by 200. I can take off 1 0. So I get 5 divided by 20. I'm going to use the black space over here. 5 goes on the inside, 20 goes on the outside. Can't divide into 5, so I need to divide into 50. 20 into 50 would be 2 times, so that would be 40. Subtract, we get 10. Add a 0, bring it down. 20 into 100 is 5. So we end up with 0.25, and 0.25 converted to a percent would be 25%. And now we need to decide, did it go up or down? It increased to 250, so this is a 25% increase. So that's how percent change works. Increase or decrease. Okay, so now they just gave us numbers. There's no really major problem here. 60 to 95, what is the percent increase? So you take your largest, 95, minus 60, and divide by what you started with. So we would divide by 60, so we get 35 divided by 60. And I've got to write that over here because top number goes on the inside, bottom number goes on the outside. So 5. Bring down the 0. 60 into 500 would be 8. That would be 480. Subtract 20, bring down the 0. 180, and now we're repeating. So 58.3 repeating. So if we convert that to a percent, we get about 58.3% increase. And this would be great if you had answer choices where you could, if it was 58 or 58.3, you could choose without having to keep going. All right, now the only difference here is instead of going up, we're actually going down. So let's see what our percent decrease is. 95 to 60. So we do the same thing. 95 minus 60 divided by. This time though, we have to change what we're dividing by. Instead of 60, we're dividing by 95. So we still get 35, and we're dividing by 95. I think I'm going to reduce this first. So what would divide into both 35 and 95? Well, your key here would be your 5s on the end. And so that's going to be 7, don't know that you can see yellow, that's going to be 7 over, well, how many nickels are in a dollar? Hopefully you know that's 20, and then 1 away, so it would be 19. So let's divide. We'll come over here. Top number goes on the inside, bottom number goes on the outside. So 70, 4, won't work. So let's go with 3. So that'll be 27, carry the 2. 57, subtract. So 13, so we end up with 130. So 54, 6, 11, 7, 60. Oh, 7's just a little too big. So go with 6. That'll be 54. Carry the 5. That'll be 11. Let's subtract. 16. Bring down another 0. 160. So we touch the board. Get it back going. All right. 7 into 19 into 160. You know what? I'm going to stop because I could keep going, but do I really need to if I just want to round to a percent? So if I'm going to round my percent and say about, which is okay, unless your teacher tells you otherwise, I'm going to look at the 6, and I'm going to use that 7, and if it's 5 or more, you move up. So we're going to have about 37% decrease. And in mathematics, guys, this is okay. This answer versus this answer isn't that much difference. And unless your teacher is wanting an exact answer, which if they do, you have to give them that, then I would be, as myself, I would be okay if they could tell me that it's about 37%. Okay? All right, moving on. And I know this is a long video, but we're almost there. We only got 2 more things to go over with percents. All right. So sometimes you hear about markups and markdowns. Markups are basically money going up or your amount going up. And so the key words here would be gratuity, and gratuity is just a fancy way of saying tip. If you're at a restaurant and you tip your waitress, you spend more on that meal because you're giving your waitress a gratuity, a tip. Sales tax, anytime we go shopping, we pay sales tax on items, and you buy a $2 item, you pay $2.08, or actually 16 cents, because our tax rate is 8 1/4, so you may pay 16 or 17 cents depending on how much it is. So markups make everything go up, and then markdowns, oh, we'll get to markdowns in a minute. Let's go through this markup amount. Okay, so a ring costs $125. You're going to use a markup of 150%. So how much is going to be the selling price of the ring? Remember back to our percent proportion that we did way back at the beginning of this video? Well, let's set that up. Okay, the ring is going to cost $125. That's what you pay for it. That is your 100%. And then you want to mark it up to 150%. And so then your is what you're looking for, or your part is what you're looking for. What is the cost? And it has to be higher than what I was doing. So now I'm going to multiply 125 times 150, and then I'm going to divide by 100. I'm going to help myself just a little bit, and instead of multiplying 125 times 150, I'm going to take off the zeros, and I'm going to reduce 15 and 10. 15 by 5 would give me 3, and 10 by 5 would give me 2, and I hope you can see that green. So now I have a whole lot easier numbers to multiply by. Again, if you're using a calculator, just multiply it. 125 times 150, divide by 100. We're going to multiply 125 times 3. And that's 15, carry the 1, that's 7, and that's 3. So we get 375. And this time, instead of dividing by 10 or 100, we need to divide by 2. So we take 375 and divide it by 2. And so either way, it's up to you. I like working with the smaller numbers. That's going to give me 1, and I'm going to run out of room. So we're going to write it over here. Divide by 2. It's going to give me 1. 2 into 17 is 8. So that's going to subtract and give me 15. 7. And then I add a decimal. 1, bring down the 0, and I get the 5. So I get 187.5. So the ring needs to cost $187.50, because that is 150% markup of what the price was. I'm sure there are other ways to do this. Using the percent proportion is, just something that you've practiced with at this point. Okay? All right. The price of a movie is $32 with 8% sales tax. How much will the movie cost? Okay. When you have a tax and a percent, you need to always convert it to a decimal. So 8, actually, I'm not going to do that. I'm going to show you using this particular percent proportion. Okay, so if our movie is $32 and that's our total, but we're going to have our sales tax, we need to add that to our total. Well, if we have 100% and we're adding 8%, what does that equal? Well, that equals 108. And then you're looking for your total cost. And so you still have your markup, okay? So you can always add your percent to 100 and set up your percent proportion. So now we end up with 32 times 108. So 108 times 32. So that's going to be 16, 2, 0, 24, 2, 3. Bring it down. So 6, 5, 4, 3. And so you end up with $34.56 is the price of your movie ticket after paying tax. Now, this is just a little tidbit shortcut. If you take this 108 and convert it to a decimal, it's still the same thing as multiplying 32 times 1.08 and still getting the 34.56. Okay. Markdowns. Last thing on this video. The keywords are discount, sale, coupon, percent off, amount saved, or what is your savings on purchasing this item. And remember, your price is going to go down. If we go back and look at our markups, 187.50 is higher than 125. Our answer is not going to be less on a markup. 34.56 is higher than our $32. It went up. So with a markdown, your answers are going to go down. They're going to decrease. And usually if you have a coupon, you're trying to save money anyway. You want your price to go down. Okay? So a ring again. A ring costs $125. You use a coupon for 10% off. How much do you save and how much does the ring cost? Okay, so they're asking us two different questions here. They're wanting to know 10% of 125, and then they want to know how much the ring costs afterwards. So let's set up our percent proportion. Our part is what we're paying. Our ring costs $125, and then we get 10% off of 100. Okay, so multiply the numbers without the letter. So just add a 0, 1250. Divide by 100. So that just means move your decimal 2 places. So we end up getting $12.50 off the ring. That's our discount. Now remember what I told you is it's going to go down. How do you make a number go down when it's a discount? Well, you're going to subtract it. So you take your 125, can't really see with red, let's try yellow, 125, and you're going to subtract 1250. Now remember, line up your decimals when you're subtracting. So you have to add the 0 here. You don't have to add the other one if you don't want to. It's okay because we know it's going to be money. So we borrow, we get 5. That'll be 4. So that'll be 2, 1, 1. So we're going to pay, the ring is going to cost us $112.50 is our cost. This is our savings. Okay? All right. Movie tickets are finally back on sale. They've hopefully are going to open the theaters soon. And they have a discount of 25%. If tickets are originally $36, how much are tickets now? So, set up your proportion. You know you have 25 over 100. And then 36 is my original amount. Is that your part or your whole? That is your whole, and you're looking for how much it's going to cost. Multiply 36 times 25. Divide by 100. I don't like doing that. I'm going to reduce my fraction. 25 over 100 is 1 over 4. Hopefully you know that by now. multiply 36 times 1, divide by 4. Well, we know 36 divided by 4 is 9. So my discount is $9. Now again, that doesn't answer my problem, does it? That tells me that they are $9 off. That is my discount. And so I have to take 36 and subtract 9, and I get $27. And so my tickets are, how much are the tickets now? They are $27 now because they're on sale for 25% off. Hopefully you can use this video to help you answer percent questions. If you have other questions or need more explanations on anything, please email me at bethemath@gmail.com. And as always, thanks for watching.